Hey Calculus, welcome back. Today we're going to be looking at applying the mean value theorem. This is a theorem that pops up both on the multiple choice and the FRQ portion of the AP exam. So I'm going to force pause on your screen. You know what to do from here. I'm going to force another pause on your screen. Can you copy the mean value theorem? So from that first sentence as well as this box here. All right, we're back. So the mean value theorem says if f is continuous on a closed interval and differentiable on an open, then there is a number c in between x equals a and b such that this is true. So this is our final statement of MVT. You want to make sure that you've got that written down. So again, our condition is that we need to be continuous on the closed, differentiable on the open. Now, for the most part, we just look at differentiable everywhere differentiable functions. So it kind of checks off both conditions for us there. So if our function is both continuous and differentiable, and remember, if your function's everywhere differentiable and it's also everywhere continuous, then there's some number in between your endpoints. So in between a and b, there's going to be some number where f prime of c, so the slope of the tangent line, is equal to the slope of the secant line. So basically, I draw the secant line, I'm guaranteed at least one other place that the slope of the tangent line is going to be parallel. So you have these two blue lines have the same slope, right? So in this case, we're using mean to mean average, okay? So that the average rate, the instantaneous rate of change at some point is equal to the average rate of change. All right, so can I ask you to pause your screen, and I want you to visualize, can you find, and there's at least two places where the slope of the tangent line is equal to the slope of the secant line. So I've drawn the secant line for you. Can you picture kind of moving that down or up? Where would the tangent line slope be equal to the secant line slope? So where would the two lines be parallel? So go ahead and pause, kind of think about that, and then we'll look at it together. All right, hopefully you paused. So if I move this down, let's see, and take this line, maybe, there we go, move it down, right about there I've got the tangent line. If let's call this like C1, for example, so right about there, and say that value is C1, but I think there is another, right, if I find another parallel line, right about there, I've got another tangent line. Okay, so let's see, right about there, I might call that C2. Okay, so the mean value theorem doesn't tell us where these C values exist. It doesn't tell us how many. It says it's just a theorem of existence. So we're just guaranteed at least one C value where you can see the tangent line slope is equal to the secant line slope. And we actually apply this theorem all the time in real life. We just don't realize we're applying it. So let's read this scenario. Suppose along an interstate, I pass through a point A on the highway at 9 p.m. and a toll booth at point B at 10 p.m. Let's say the 2 points are 100 miles apart. The speed limit on the highway is 75 miles per hour. Using the mean value theorem, or MVT, explain why an officer has the right to give me a ticket. Well, my average speed was 100 miles per hour, right? So by MVT, I had to have been going 100 miles per hour at least some point, right? So, we're applying MVT all the time. I know that my speed is continuous and differentiable, so I must have been going 100 miles per hour at least one moment in time, probably more. Also, may the record show that as of October 27th, 2020, I have never had a speeding ticket, so we'll see how long I can keep that up. Okay, all right, well, you go ahead and write that equation for me in your notes one more time. And I'm really going to get some good terminology here for you. So under the C prime, so I've kind of divided this up, f prime of c gives me the instantaneous rate of change. Okay, so underneath that, can we do maybe like a little arrow or however you want to label it? That f prime of c gives me the instantaneous rate of change, and this will be at one value. So I'm going to put at x equals c, right? That's the derivative. Now the right-hand side, that's just regular old slope between 2 points, right? So this gives me the average rate of change over an interval a to b, okay? So that's some vocab for you. The left side gives you instantaneous rate of change, the right side gives you average rate of change. And you may or may not see that word instantaneous. So if you don't see it, it's understood. Okay, you have to see average to mean average rate of change. I can also think of this in terms of slopes. So the left-hand side gives me my slope of the tangent line at x equals c. The right-hand side gives me the slope of the secant line between a and b. All right, so go ahead and pause the screen. Make sure you've got everything on the screen copied. All right, can you go ahead and just in your notes, all you need to do for this example is write f of x is x cubed. So the application of MBT to f on the closed interval 0 to 1 guarantees the existence of a value c. And remember that c has to be between 0 and 1. It can't be equal to 0 or 1. So first find what f prime of c should equal, so the average rate of change, then solve for c. Okay, so let's just come to the side here. Let's get in this habit of writing our final formula for MBT. It's f prime of c equals f of b minus f of a all over b minus a. And what I'm going to do is work with this f of b minus f of a over b minus a first. Okay, so it said first find what f prime of c should equal. Okay, so let's find the average rate of change. So what is b in this case? B is 1, and what is a? A is 0. So I'm going to set it up like this. F of 1 minus f of 0 all over 1 minus 0, right? And by the way, I should note that f is a polynomial, so it's both continuous and differentiable. All right, f of 1, if I plug it into the original, I get 1 cubed, which is 1, minus f of 0, 0 cubed is 0, all over 1, so meaning that the average rate of change is 1. So I have found the right-hand side of MBT, right? So now let's find f prime of c. Well, f prime of x is 3x squared. So f prime of c will be technically 3c squared. A lot of people just keep it as an x. As long as you know that that's what you're solving for, I'm fine with that. So I'm going to take the derivative, right? F prime of c, I took the derivative there, equal, and now set it to the average rate of change, which we got to be 1. Okay, so again, the left side gives me my instantaneous rate of change, f prime. My right side gives me my average rate of change, that change in y over change in x, f of b minus f of a over b minus a. Okay, now we just solve for c. So let's divide both sides by 3. Take the square root. Don't forget your plus or minus. And then we see, do I want both? Do I want neither? Do I want one? Well, let's take a look. Our interval was from 0 to 1, so only the positive branch will work here. So that is what our c value should be. That's our final answer. So I'm going to show you graphically what's going on here. So the red curve is f of x equals x cubed, but notice that I only graphed it from x equals 0 to 1, which is why it doesn't really look like your traditional cubic function, right? Because I really kind of zoomed in, okay? Now that blue line is your secant line. That's its slope is that f of 1 minus f of 0 over 1 minus 0. And take a look at that slope. I can tell, yeah, that is rise of 1, run of 1, right? So this is your secant line. And you can see that the purple line is parallel to the blue, right? Meaning that their slopes are the same. And this is it's about 0.57, which is your square root of 1/3 x value. And again, this purple line is your tangent line at x equals square root of 1/3. And you can see again the purple and the blue are parallel, so we did good here. Okay, I'm going to force a pause on your screen. Can you copy this in your notes, and then we'll try it together. Okay, we are back. So if c is a number that satisfies the conclusion of MBT, remember the conclusion is that f prime of c equals f of b minus f of a all over b minus a. For f of x equals x cubed minus 2x squared on the interval 0, 2, then what does c equal? Okay, well, let's kind of just write all of this. Let's start here with our conclusion of MBT. Again, I'm looking at a polynomial, so I know we're good to go. My conditions are met. It's differentiable and hence continuous. Now, what is your A value? A is 0 and B is 2, okay? So, and then I've got the derivative here. So let's work with the derivative first. The derivative is going to be 3x squared minus 4x, right? So if I'm evaluating at C, I'll have 3c squared minus 4c. And if you would rather just use x's, that's fine. I just want you to know what you're solving for there. Now let's work on f of b minus f of a over b minus a. All right, so I'm going to have, let's plug in 2 for b first of all and 0 for a so that we know where we're going with it. Okay. All right, so the left side looks good to go. Let's keep working with the right side. F of 2, if I plug that in, I'm going to get 2 cubed, which is 8, and then I'm going to get minus 2 times 4. So it looks like I'm getting 8 minus 8, which is 0, right, for f of 2. Now if I plug 0 in, once again I'm getting 0, right, all over 2. But 0 over 2 is what? Is 0. So I'm getting that. Okay, so now I want to solve for c. I'm going to go ahead and factor out a c, so I'm getting 3c minus 4 in parentheses. So c, so, and again, make sure you're factoring and not dividing, okay, so you don't lose solutions. So I have two options for c right now, arithmetically. I've got 0 and I've got 4 over 3, okay? Now it's multiple choice, only one of these answers can be correct. Which one do you think is correct, 0 or 4/3? 4/3 is correct. 0 is not valid, nor is 2, because it has to be a c value inside my interval for the conclusion. So I need to toss 0, and that is why only D, as in dog, is correct. All right, good job, you all. I will see you next time.